Okay, here's my video for question 5-45 and 5-46 from the homework 514. Okay, the first one here, 5-45, is a probability union and intersection problem, and we're evaluating a deck of cards. Okay, and it's saying that there are 13 club cards in a deck of cards. There's the 1 through 10, and then the 3 face cards, king, queen, and jack. And so we're going to look at the probability of getting a club or a face card, the probability of getting a club and a face card, and then determine whether that's a union and intersection. And then we're also going to look at the probability of it not being a club or not being a face card. Okay? The first thing I want to talk about in the video to help us get going is flashing back to lesson 424 where we talked about union and intersection. In this lesson, we see that if it's an and problem, first chip and winning the bet, is going to be an intersection. So anytime you see that word and in a probability problem, we can think intersection because that is the one event happening and the other event happening. So there needs to be some overlap there for the one event and the other event to happen. Now, the other part of this lesson talked about the union. And anytime you see the word or, that is going to be a union because that is one event happening or the other event happening, meaning you could get a number in the first event or a card in the first event or a card in the second event. And that's going to be this idea of a union or combining the sets. Okay, so in this problem, what I'm going to do is draw out the sets so I can see where I have this overlapping and where I have the separation and how I can combine the two. So my first set is just going to be of all the club cards. And all the club cards are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. Those are all my club cards. Now I'm going to write out the set of all of the face cards. And remember that these are all club cards here. So I'm going to put a C for all the club cards here. All right. And so writing out all the face cards, well, I have jack, queen, king of clubs. And I'm putting a C over top for clubs. I have jack, queen, king for spades. I have jack, queen, and king for hearts. And I have jack, queen, and king for the diamonds. So these are my two sets, all the face cards in a deck and all the clubs in a deck. Now I'm looking for the probability that I get a club or a face card. And remember, or is going to be the union. So I want the union of these two sets, saying that I pull a card from either the first set or the second set. Okay? And really when it's a union, I combine the two sets and just do not repeat the intersection or the ones that repeat in both sets. So if I'm going to write out my total union set, it's going to be all the clubs and all the face cards. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I have the jack, queen, king of clubs. I have the jack, queen, king of spades. I have the jack, queen, king of hearts. And I have the jack, queen, king of diamonds. Okay, that is my total union set because I can either win or pull a card from the clubs, or I can pull a card from the face cards. And so I can count the number and I can do my probability. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 total cards in this union set. And so I can say, well, for the probability of this hitting, there is 22 cards out of a total of 52 cards in my union set. And this, again, would be an example of a union because it's the combination of those two sets, one or the other set hitting. If I'm looking for just a club and a face card, that means it needs to meet both. I need to pull a card that is not only a club, but it's a club face card. So I'm looking for the intersection of these two right here. And the intersection is just the cards that are repeated in both the first set and the second set. And the cards that are like that are the jack of clubs, the queen of clubs, and the king of clubs because they appear in both sets here. And so my union set is just 3 cards. It is the set of Jack, Queen, and King of clubs. And so if I'm talking about the probability of this hitting, that is 3 cards out of the total 52 cards, and that is an example of an intersection because it has to be the cards in one set and the other set, the cards that exist that are clubs and face cards. Okay? If I'm looking for then the probability of not a club and not a face card, that is going to be the complement to my part A. Meaning this is the probability of a club or a face card, and I want the probability of not a club and not a face card. So it's the opposite of this one here. And to do the complement, what we can do is 1 minus our probability of the club or the face card. So that would be 1 minus 22 over 52. Now rewriting this so I can actually do the subtraction, I'm changing the 1 to 52 over 52, so I have a common denominator, minus 22 over 52, and I get, when I do the subtraction, 30 out of 52 cards. So there are 30 out of the 52 cards that are not a club and not a face card, and that would be my probability there. Okay? Going on to this one here, this one's a little tricky just because they don't want us to use a calculator on it. Okay? So what we're going to do is we see that they gave us the sine of 23, they gave us the cosine of 23, and they gave us the tangent of 23, so we don't need our calculator to do that. Well, I'm looking at this triangle and I don't see a 23, but I can create one, or I can draw one in here because I see that this is 67, this is 90, so the amount of degrees that are left in this triangle for the last angle is 23. So this angle down here is 23. Now I can use that 23 to try to solve this here for x by setting up this trigonometry problem. Well, if this is my angle 23, then 18 is adjacent to that, and x is my hypotenuse. So I know if I want to solve for x, this is going to have to be a cosine problem using the angle 23. So I can set this up using the cosine of 23 equals the adjacent divided by the hypotenuse, which is 18 divided by x. As always, I like to put my cosine or any kind of trigonometry problem over 1 so I can cross multiply here. And before I cross multiply, I'm going to replace the cosine of 23 with the decimal that they're giving me up here. Okay, so this can be written, instead of like this, I can write it as 0.921 over 1, just replacing the cosine with its decimal value, set equal to 18 over x, and I can cross multiply and solve. 1 times 18 gives me 18. The 0.92 times x gives me 0.921 times x. Now to get x by itself, I need to divide by 0.92, and so I get x equals 18 divided by 0.921, and I'm not going to use my calculator because the problem doesn't want me to, and I'm just going to leave it as that for my x. If you want to solve it and divide it, you definitely can. I would not be against you using your calculator for that portion of it. Okay. Now we want to do part B, where we can find the sine of 67. Okay, and this is, we can see we have a 67, and let's just set it up so we can see it like this. Okay, if I do the cosine of 23, which I just did, the cosine of 23 equals 18 divided by x. Okay, and so we know that the cosine of 23 is 0.921 equals 18 over x. Now if I want to figure out the sine of 67, so I'm going to erase this and I'm going to kind of look at this angle 67. Well, that means the 18 is my opposite because it's across from my 67 now, and the x is still my hypotenuse. And so I can set the sine of 67, is equal to the opposite divided by the hypotenuse, which is 18 divided by x, which now I can see that the cosine of 23 equaled 18 over x, and I have the sine of 67 equaling 18 over x. So these two things must equal the same thing, okay? And so that means the sine of 67 is also 0.921 equals 18 over x. And this happens in any triangle, Okay, the cosine of this angle, of the angle 23, is the same as the sine of its complement angle, which would be 67 in this case. So both of them here equal that 0.921 because they both equal 18 over x. Okay, it's kind of a weird rule there, but it just goes to show that just depending on what angle you choose, the cosine and the sine are both viable options to still get your answer. Sorry the video got a little long. Hopefully this addresses your questions. If you have any further questions, make sure you reach out and ask.